Okay, so again, very good morning, friends. In this video, we are going to discuss idea of the limit with the help of some examples, and we are trying to solve some questions from the IIT. And these questions have come in the past in the IIT, JEE entrance examinations, particularly the main, and way back in 1996. This question. Now it goes like limit x tends to 1. X plus 2 over x square minus 5x plus 4 plus x minus 4 upon 3 x square minus 3x plus 2. Rule says that if I find the limit, like this question is like this. So rule says that you can find the limit individually, and then suppose if I put the value of 1 directly here, then I get 2 plus 1 3 upon, then here you see 0, 3 upon 0, and if you put the here something, get the minus 3 upon 3 times 0, means you are getting your answer as undefined. It means this we cannot do. And here you see that there was certain questions in the past, in the previous video I have discussed, that when you're putting the value of x as 1 in the numerator and denominator, then both the numerator and the denominator simultaneously became 0, and we got 0 by 0 form. Then using the idea of the factor theorem, we got that since x minus 1, like suppose it means if x is 1, making the denominator and the numerator both vanish, it means x minus 1 is the factor of both the numerator and denominator. So we simply factorize the numerator, denominator, and cancel the x minus 1 factor, and we got our answer. But here you see we are not getting 0 by 0, we are getting 3 upon 0. Means this x minus 1 is the factor of this, but it is not the factor of numerator, so you can never cancel them. Here also x minus 1 is the factor of this but not of this, so it means this idea is not going to work. So suppose first I write in the x factorized form. If you factorize this directly, you get x minus 4 x minus 1. Since you are preparing for IIT, you must know this, otherwise it is simply that x square minus this 4, two factors of the 4, that is 4 and 1, plus 4. So this becomes x square minus 4x minus x plus 4, x common, x minus 4 minus 1, x minus 4, x minus 4 common, x minus 1. But in the IIT, you do not get so much time to solve questions like this, so you can directly need to know if you have studied the quadratic equation. Otherwise you can watch my previous videos, quadratic equation, where you will find how to factorize these two quickly. So x plus 2 over x minus 4 and this, and plus this is x minus 4 over 3, sum of roots, so it is x minus 2 and x minus 1. Now you see x minus 1 is common to both, so first you write limit x tends to 1 here like this, and then I try to take the x minus 1 as common, 1 over x minus 1 common, then I get x plus 2 over x minus 4 plus x minus 4 over 3 times x minus 2. Now here it is again limit x tends to 1. This is limit x tends to 1, 1 over x minus 1, and then I try to take the LCM. So x minus 2, x plus 2 plus x minus 4 whole square over x minus 4 3 times x minus 2, like that. Now this one is 3 times x square minus 4, a minus b, a plus b, plus this is x square minus 8x plus 16 over 3 times x minus 4 x minus 2 over x minus 1 limit x tends to 1. So limit x tends to 1, 1 over x minus 1, and denominator is 3x minus 4 x minus 2. Now I just say 3x square, and this is 4x square minus 8x, and minus 12 here, and plus 16 is 4. So is 4 is common, so I can write 4 over x minus 1, and what become x square minus 2x plus 1. If you see it properly, this is nothing but x minus 1 whole square. So 3x minus 4 x minus 2. So now just check it out, this one, what is this? 4 x minus 1 whole square over x minus 1 3 times x minus 4 x minus 2, and limit x tends to 1. This power cancel this one. Now there is no x minus 1 factor in the denominator, so denominator is not going to be 0, because when you put x is 1, so you see now the numerator is 0 but the denominator is non-zero, so the answer is 0, and that is the value of this question, that the answer is 0. Now I'll try to elaborate with another example. So just let now I take another example. This is also from the IIT in the past, and this is in the 90s question. This is limit x tends to under root 2, and the fraction is root 3 plus 2x. Root 3 plus 2x minus root 2 minus 1 upon x square minus 2. Okay, now here you see x tends to root 2, and this one is x square minus 2. It means it has got the factor x minus root 2, and that is the reason why this whole thing is becoming 0. How? So you see this is root 3 plus 2x minus root 2 plus 1, and this one you can write it as x square minus root 2 square. Root 2 square is this, so I am not wasting my time. I simply remove, and then I write x minus root 2 x plus root 2, limit x tends to root 2. Now this x tends to root 2 and this x minus root 2, these two, because when is x tending to root 2, therefore x minus root 2 tending to 0, and this is what's making it 0. It means I have to get rid of this x minus root 2. So I can do that. Here you see this is called surd. So I need to rationalize the surd, and you know that if you want to get rid of a surd of the order root a plus b, then you have to multiply it with root a minus b, so that it becomes root a square minus b square. So here I multiply this with root 3 plus 2x plus root 2 plus 1. This is minus, that's why I multiplied, so that it's a minus b form, and I am multiplying it by a plus b. So a minus b into a plus b will become a plus b. So this is individually it become the difference of the squares of these two, so root will be gone. So now this, and again you multiply the same thing up and down, plus under root 2 plus 1. So now here root is gone, so you are getting 3 plus 2x minus this one term will be squared, that is 2 plus 2 root 2 plus 1 upon x minus root 2 x plus root 2 into this is gone. So now again I am left with 1 over root 3 plus 2x plus root 2 plus 1. So now here you see that this is 3 and 1 and 2 3, so you are getting 2x minus, because when you dissolve this bracket become 2x minus 2 root 2. So if you take 2 common, it becomes x minus root 2 x minus root 2 x plus root 2 1 over root 3 plus 2x plus root 2 plus 1, and the limit x tends to root 2. This 2 cancel. Now you put the value of limit. So replace everywhere, replace x by root 2. So root 2 plus root 2, this will become 1 upon 2 root 2, and here it is 1 upon root 3 plus 2 root 2, so you'll get root 3 plus 2 root 2 plus root 2 plus 1, and that is your answer. This is how this question can be solved. So now that we clear the mess again I'm giving you one very powerful and beautiful question to solve another example. So now this is the answer. This looks very weird, so we have to check whether it can be simplified any further. So now look at this question, this part, that is root 3 plus 2 root 2. What if this is a perfect square? Now you see that I write in the root, so I write 2 means I can write 3 as root 2 square plus 1 square plus 2 dot root 2, that is root 2 plus 1 whole square inside the root 2, that is root 2 plus 1. So it means this is nothing but the root 2 plus 1. So now my whole thing can be arranged as 1 upon this one, 2 root 2. This is 1 upon root 2 plus 1 plus root 2 plus 1. So this will become 1 upon 2 root 2 into 2 root 2 plus 1, that is 1 upon 4 root 2 root 2 plus 1. This is your final answer. So now I need one more question to explain the idea. So I'll take one more question, I'll try to solve one more. Okay, so I made up one mistake here. I forgot to write this 2. It should be here, it should be here. Now these two cancel, so this should not be here. And then if root 2, like suppose I'm getting this term, so I keep the 2 outside. So this is 2, and I put this root 2 inside. The root 2 into root 2, this will become 2 plus root 2. So this way you can explain this answer, and this is all. Now here we have another example, and this is the difficult question. Limit n tends to infinity. N tends to, this is limit. So limit n tends to infinity, and this is called the pi, means product form. Pi from r equals to 2 to n, and the expression is r cube minus 1 over r cube plus 1. So pi is product. Starting r's value will be starting from 2, and continuously it will go to n, and then each term will be multiplied with itself. Just like if I say that pi r equal to 1 n r square, this means 1 square multiplied with itself. 1 square into 2 square into dot dot, finally it will be n square. It goes like this. So the same thing here, what will have, limit n tends to infinity, and this will be first starting with 2. So this is 2 cube minus 1 upon 2 cube plus 1 into 3 cube minus 1 upon 3 cube plus 1 into dot dot dot, and final term will get n cube minus 1 upon n cube plus 1. Now we know the formula of a cube minus b cube. So a cube minus b cube is a minus b, a square plus ab plus b square. So this will become 2 minus 1, 2 square plus 2 plus 1, and a cube plus b cube, a cube plus b cube is a plus b, and this is a square minus ab plus b square. This is 2 plus 1, this is 2 square minus 2 plus 1. Now same way, this is 3 minus 1, 3 square plus 3 plus 1 upon 3 plus 1, 3 square minus 3 plus 1 into dot 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 into this, you'll get n minus 1 n square plus n plus 1 upon n plus 1 n square minus n plus 1. So let me find some pattern. So this will become limit n tends to infinity, 2 minus 1 1 upon 3, and this is 4 plus 2 6 plus 1 7, 7 upon 4 minus 2 2 plus 1, this is 3, 4 minus 2 plus 1. Okay, now this 3 minus 1 2 upon, this is 4, this is 9 plus 3 12 plus 1 13 upon 9 minus 3 6 plus 1 7 into, suppose if I take 4 also just to check what possible term I am getting, then I get 4 minus 1 4 square plus 4 plus 1 upon 4 plus 1 4 square minus 4 plus 1, that is 3 upon 5, 16 plus 4 20, and this is 21 upon 16 minus 4 12. So I get one more pattern, that is 3 by 5, 3 by 5 into 21 by 13 dot dot dot. I write this as n minus 1 n square plus n plus 1 over n plus 1 n square minus n plus 1. So now here you see that we are getting 7 here, 7 here, 3 here, 3 here, 13 here, 21 here. So we'll get a pattern something like this. So this 7 gets cancelled, this 7, this 3 gets cancelled, this 3, and this 13 gets cancelled with this 13. Similarly we can find another 4, but you'll never find any contemporary term for these two. So it means from this everything will be cancelled, and then we will find 1 dot 2 dot dot dot, and then this term, that is n square plus n plus 1. This will also be get cancelled by something n minus 1, it is here, and then in the denominator you will find n plus 1. 1 n is here because it is n plus 1. So the previous term here you can express, you can find something n here, and then this n and this 2 will also not be cancelled. So you get something like this. Now this is, we have to solve this question because all these are multiplied. So now one more term I forgot here, this 3 will also be there. So now you see we have got our final expression as limit n tends to infinity 2 by 3 n square plus n plus 1 upon n plus 1, that is also n square plus n. So I get 2 by 3 limit n tends to infinity. Now I will divide both numerator and denominator by n square. So I get 1 plus 1 by n plus 1 by n square over 1 plus 1 by n. And since if n tends to infinity, therefore 1 by n tends to 0. So you will get 2 by 3 into, that is 1, and your answer will be just 2 by 3. So this is how the ideas of the limit can be solved. There are many questions, there are many formulas. All you have to practice, because it is not possible for anyone to make videos by solve. But I'll try to upload as many videos possible by solving those questions which are inevitable, common and good for understanding the concept of limit. Thank you very much. Just subscribe to our channel and keep growing with us.